All right. Good day, makers. Hello, everyone, and welcome back to another Tokens on Bitcoin workshop. Today, we are joined by Hannah from Lightning Labs. She's a developer advocate over there, and she's going to be giving us a workshop building on Taro, which is Lightning Labs' new Taproot-powered protocol for issuing assets on Bitcoin. I'll keep it short on my end today. I'll hand it over to Hannah. I'm really looking forward to getting into this one. If at any point anyone has any questions about Taro or any of the things which Hannah is presenting on today, feel free to just drop your questions or comments in the YouTube comments, and we'll get Hannah to answer them. Hannah, would you like to answer these questions live as they come through, or do you want to just do them all at the end? It's kind of up to you.
I think it makes it a lot more fun if we sort of have a running conversation throughout the workshop. So I don't know. I don't think I can see the comments here. Hold on. Maybe if I switch over there. There we go. I can see them. Okay. So yeah, I will pause throughout the presentation to have time to answer questions. And if I can, as they pop up, I'll answer them as well. So definitely ask all the questions all the time.
Cool. Alrighty. Well, over to you, Hannah. Thanks again for being here, and looking forward to it.
All right. Thank you. Okay, so today we're doing a workshop or demo on Taro. So we are running Taro today. And let me go through, hold on, got a couple of screens going. There we go. All right, so this hopefully is the appropriate link to get you the full slide deck here. So you can, if you're, what we're gonna do is just a very, very brief overview of Taro, because I know Leo did one, a much more extensive one earlier in the week. So we'll do just that very, very briefly, and then we'll go into a demonstration. And it would be really awesome if some of you want to follow along and do this with me and set up Taro yourself. If you do it on a testnet node, then we can maybe even send each other some assets during this demo, which would be super fun. But if you want to sort of look ahead at any of the instructions or just have these slides for reference, hopefully this link works. Let me know if you have any trouble with it. All right, so we'll start off with introductions. I'm Hannah Rosenberg. I generally don't do workshops this early in the morning, so I feel like I might be a little bit too caffeinated, so I'll try and slow down so we don't go through this too fast. But this is the very caffeinated version of the Taro workshop. But more about me, I work as a developer advocate at Lightning Labs. So it means it's my job to talk to all of you about, using this tech. So please do have a conversation with me and ask lots of questions. Let me know if you run into any problems, etc. All right. I've been in the Bitcoin world for a long time. Some of my Bitcoin resume is up there on LinkedIn if you're interested in that. And then, of course, I am on the Twitters, and that's where you can find me. All right, so about you. I've made a few assumptions about all of you all, which I think are pretty valid for this particular workshop. I'm assuming that you are all tech-savvy Bitcoiners and that you know what a Bitcoin UTXO is. So that's the base level of knowledge that I'm assuming for this workshop. All right, how many of you, if you just want to tell me maybe in the comments here, like just give me a thumbs up or something, or if you plan to actually install Taro today and try running the Taro daemon during this workshop, let me know, because then we can, I can make sure that I'm working with you to see if you run into any issues, etc. If you are going to do this along with me today, you can either install Taro on your local machine using Bitcoin's reg test, which I'll suggest doing via Polar, and I'll give instructions on how to do that. Or if you already have an LND testnet node up and running, we can do it there, which would be fun too, because then we can maybe even send each other some assets, which would be super cool. All right, looks like Chris is gonna give it a try via Polar. That's awesome. All right. And what do you hope to learn here? So if there's something specific that you're hoping to get from this workshop, of course, I've already planned all of the content, but if there's something specific that you'd really like to get out of this, let me know, and I will try and get to that if we can. Cool. All right, about the workshop. The goal is for all of you to leave this session knowing more about how to use Taro than you did when you started. So if we achieve that, then mission accomplished. So to that end, please ask many, many questions, right? If the question helps you learn more about Taro and using Taro, then it's a very good question, and please ask it. We'll do that in the comments. I'll answer them as I can as we go, and then we'll stop periodically during the demo here to pause and see if anyone has any additional questions. All right, so of course, live demos always go exactly as planned, never any problems, but just in case we hit any issues with the demo today, please bear with me. I am in Puerto Rico, which notoriously has a not so great electrical system, so if I just disappear for no particular reason, maybe the electricity's cut out, I'll be right back. So bear with me. All right, what we'll cover. The Taro daemon. That's what we're going to be talking about mostly today. So what I'm going to walk through, again, we'll do a very brief, like 5-minute Taro 101 type thing. And then we'll get into how to download the Taro repo, and install Taro. We can do that. I'll show instructions on how to do that both via puller and on an LND testnet node. What I'm going to be showing here is I have a testnet node that I use for a lot of this sort of demo type stuff. It's a Ubuntu server, and I'm running LND on that Ubuntu server. So that will be all of what I'm going to show here are, Ubuntu command line sort of stuff. All right, we're going to talk through how to connect Taro to a puller node. We're going to talk about making custom puller nodes, which is necessary at the moment because this is brand new stuff, right? You have to switch to a specific, the master branch of LND, etc. All right, then hopefully we'll get to actually mint some assets. We'll see how we go. All right, so if you do want to participate and install Taro as we do this, this is what you'll need. You'll need Linux or Unix command line familiarity. You're definitely going to need Go 1.18 or greater. If you're doing it on the testnet, then of course you need a testnet node that you have command line access to. If you're doing it via regtest and puller, well, then you need to install puller. And you also, puller has some Docker dependencies. So you need to go ahead and install that. So for anyone that wants to follow along, again, this is what you'll need. And if you do want to follow along and install, now is a great time to go, get any of these dependencies that you don't already have. Okay. So I see no questions at the moment in the chat. So we'll roll right along. I'm going to put on my timer here because I'm aiming to do about just a very brief, maybe 5-minute overview of the Taro protocol, just to make sure we're all on the same page. And of course, this gives you a chance to go install puller or whatever, Go, whatever you need if you want to follow along with the demo. All right, so the Taro protocol. All right, what is Taro? Taro is Taproot asset representation overlay, right? It's a really clever way to basically create assets and commit to them via the Bitcoin blockchain, right? So it uses all kinds of Taproot stuff, and we'll get into that in a little bit. But the idea is to take these assets, create them. We'll talk a little bit about the data structure that's used to create them, and then commit to them by say embedding them, but it's more like just committing to specific data in a Bitcoin transaction, in a Taproot transaction. So we'll talk a little bit about how that works. So Taro uses Taproot, right? Taproot makes this possible. So we have to talk very briefly about what aspects of Taproot Taro uses. All right, so cool Taproot stuff. We have Schnorr signatures. We have tapped script, which is very briefly sort of the idea of taking Bitcoin scripts, but then sort of embedding them in these Merkle trees. So you have different options of which ones to use. All right, then we have tap tree, right? That's this sort of Merkle tree of different script options that you can use. And then what we'll talk a little bit about is tap-tweak. Tap-tweak is really, really cool because it creates a way for us to commit to all this data, right? All the data that is are these Taro assets in a Taproot transaction that looks like any other Taproot transaction. So it doesn't cause blockchain bloat. We don't need to use op return. It has privacy features because it just on the blockchain appears just like a regular Taproot transaction. So someone isn't necessarily going to know that in that transaction, are 100 HANA coins or 1,000 or 1,000,000, whatever it may be. So it's pretty cool. And we'll talk briefly about how tap-tweak works. So to commit to data, we tweak the public key of our Taproot spending key using a trick known as tap-tweak. It allows us to selectively reveal the data without revealing the private key or spend the output without revealing the commitment. All right, this technique is used in Taproot transactions to commit to the Taproot script tree and can be used to commit to any arbitrary data. So here is the math for the math nerds. But the idea here is that we take, and we'll talk briefly about all the Merkle trees that are used to create these assets and commit to them and provide proofs for them, etc. But you take all these trees and within trees, it's Merkle trees inside Merkle trees, it's complex data structure. But you take all of that, get all the way down to the root hash, and then you sort of embed via this, fancy math here, you then embed that data into the public key, which then becomes like the address, the Taproot address. So via that whole process, we can take all of this data, which is our Taproot assets, and shove it into, or our Taro assets, and shove it into a Taproot transaction in a very elegant way, which doesn't cause blockchain bloat. So super cool. So very, very briefly, we'll walk through how this works because we got about 2 minutes left in our brief 5-minute overview. All right, so adding Taro assets to a Bitcoin transaction. This is a not strictly technically accurate, but hopefully very helpful way to visualize what's happening here. So here we have a Taro Merkle tree. We keep that root hash. We go and we add it to this Taproot root hash, and then that via tap-tweak goes into a sort of becomes a Bitcoin UTXO. It's kind of how you can think of that. So let's skip here. So here you can see we kind of have these inputs in a Bitcoin transaction, and in this UTXO, in this Bitcoin UTXO, in this output here, we have our Taro root hash, which goes into the Taproot tree, which gets embedded in a Bitcoin transaction via tap-tweak. We're about at the 5-minute mark. So we'll just go over the benefits here. It's indistinguishable from a regular Taproot transaction. It doesn't cause blockchain bloat because we're not using op return and these sorts of other things. It's entirely opt-in, right? You can be running a Bitcoin node and not care about Taro at all and never need to care about it, right? Doesn't matter. And there's no need for a Bitcoin node to run Taro. Taro data, I like to think of it as it isn't so much on the blockchain as it's kind of just committed to via the blockchain, right? We just periodically create these new UTXOs which have, that data, the hash of that data embedded in it. So we're sort of just periodically committing to this data. All right. So we are at the 5-minute mark for our brief Taro overview. We have here struggling to see the woods from the trees. Yes, I know. It's like Taro, it's like so many Merkle trees. It's like Taro is just a Merkle forest, many, many trees. The trees that I'm showing here are, not strictly technically correct. They're very simplified just for demonstration, but actually, you look at the actual tree structures there, it's a lot, right? It's definitely a Merkle forest. All right, so the type of trees that we're using is a sparse Merkle tree combined with the Merkle sum tree, which creates a Merkle sum sparse Merkle tree. But we won't really get into depth on that. We'll just show that, you can use the hash of these assets in binary form to find the, where this particular asset lives in a tree. So this is important to the data structure because you can locate an asset in a tree. Also, Merkle sum trees mean that you can, each sort of leaf on this tree kind of has a value, and then as you hash your way up, you have sort of a sum at the root of all of the values that live in there, which allow you to, provide proofs that mean that you can prove that you're not inflating assets, right? So this is cool stuff. Again, we won't dive into it because Leo covered all this stuff earlier in the week. We'll talk very briefly here about asset transfers, internal transfers versus asset splits. Just kind of different way to think about it. If I have 10 Hana coins here and then I send them to someone else, you kind of have to think of the different layers of keys. There's that top layer, which is, the Taproot on-chain keys that someone might control. In this case, I'm sending someone in a split transaction. I'm sending them an asset, which sort of creates a new Merkle tree in a different Bitcoin UTXO that then, if I'm sending this to Bob, Bob would then have control of that Bitcoin Taproot key that allows him to control those assets in that UTXO. It's a little bit different from an internal transfer, which is kind of just moving assets between, you can think of it as like different leaves of the tree. And then here there's different sort of sets of keys. One person might have the top level Bitcoin UTXO key. And then, Alice and Bob down here would have keys that allow them to control their leaves on that tree. But again, won't get too in depth with that. Here's some further reading if you're interested, just to the docs. And the Taro intro video, we do now have, just earlier this week, we released the Taro demo video, which is just very brief, maybe I think less than 6 minutes overview of, again, just setting up Taro, installing Taro. Cool. So we will pause there. Hopefully anyone now that has wanted to follow along and do the install has whatever dependencies they need. Any quick questions on that brief overview before we dive right into actually using this stuff? I will pause for a second to see if anyone pops up with any questions. Doesn't look like it. So water break, and then we're back to it. Okay, cool. All right, so let's get straight to actually installing Taro. Cool. 2 of you say that that's pretty clear overview. Excellent. Let me know if anything gets confusing here. All right, so again, what you'll need to participate. You have to be familiar with the Linux examples that I'm giving here. You need Go. If you're doing this on Testnet, you'll need a Testnet node up and running. You need command line access to that. If you're doing it via Polar, then you need to install Polar, and that has some Docker dependencies. Okay, so we'll start first with walking through how we can install this with Polar. Anyone who's not familiar, Polar is this really cool application that has this great UI that allows you to sort of create a Lightning network. Just all using, on your local machine, using Bitcoin's reg test, and it uses, Docker containers, and you can, create an entire Lightning network. So you'd have to have like a Bitcoin node and an LND node, maybe some other Lightning implementations, and you can create this whole little local Lightning network, which is hugely handy if you want to test something out, test a setup. You can set it up so you can test, sending different type of Lightning transactions between different nodes, or test routing, all kinds of stuff. And of course, here we can use it to test out Taro and creating and perhaps even sending, although I won't demonstrate setting up different versions of Taro, but you could do that, use it to demonstrate, test out sending Taro transactions or assets. Cool. So the Polar setup. All right. To try out Taro on your local machine on a local reg test network, step 1 is to get Polar installed. Lightningpolar.com is where you can do that. All right, so one trick here, because of course Taro is so new that we have to jump through a couple of hoops to actually get it working, because it's not really, well, Taro is being built to work with LND version 0.16, but that's not out yet. So if you want to try using Taro, you need to connect it to an LND node that's running on the master branch. So you need to have an LND node running on the master branch. That's not built into Polar by default at the moment. So we need to build a custom Docker image that we can then import into our Polar network so we can connect it to Taro. So you can follow along with Jamal. Jamal wrote Polar, and he created these instructions here for setting up, for creating these custom Docker images of LND or other Lightning implementations as well. So if you're following along, you're going to want to grab that URL right there. It's at GitHub, Jamal, JSR, Polar, Blob, Master, Docs, custom-nodes.md. And if you go there, those are the instructions, and you do, we'll walk through what we're going to do, but you will need some information that's on that link. So if you're following along, please do go to that link. Cool. All right. So first thing we have to do is just pull LND down to our local machine, because what we're going to do is build a custom image of LND via Docker. So we just go git clone, pull down the repo, cd in there. There is a Docker file in there, and you're going to open that file, then take the contents that Jamal provides in that link and overwrite that file with what's in the contents of that file via the link. So you have to overwrite that file. Then you create the docker-entry point.sh file and add the contents from the link. So you create that file and then go back to the link with the instructions that Jamal provides, copy the contents of that file in there, save it. So he's done, gone through all that work for you. All you have to do is copy paste and then run this command. Docker build -t lnd -master dot, right? You run that command and give it a minute to build that Docker image for you. Okay, and hopefully if that goes well for you, you get your output should include successfully tagged lnd-master:\latest, right? That's what we want. All right. So then we have to import the custom image. Essentially, what we have created is a custom Docker image for LND 0.15.99-beta. And we'll need to then import that into Polar, into a Polar network. So again, Jamal provides some instructions here, although this one will walk you through it. But again, there you can have a look at the specific instructions for importing that custom image into Polar. All right, so here's a screenshot of that. What you do is first is run Polar. So on my machine, Ubuntu machine, right, it's just an app image. You just make sure that app image has the right permissions, and then just run it. And you get this beautiful UI. So then you have to click Manage Images. So up in the top corner, I think y'all can see my cursor. Yep, up here, you click on Manage Images. And then you click on Add a Custom Node right here. Boom. Then you get these options here. So you enter a name. I just do LND master or whatever you want to call it. Make sure it shows the LND implementation. And then in this Docker image section, you can just start typing LND-master, and it should pop up and show that option. And then you can just click on it. You can leave this stuff alone and hit save. When I did this, one of the times I did it, wound up with an error. And so I had to just go and check either the permissions on either the app image for Polar, or Polar also creates this directory on the Ubuntu machine. It'll create this directory .polar. and you just have to make sure that has enough permissions to run as well. So if you hit any errors at this point, just go check the permissions on those files in that directory. Okay, any questions thus far? Oh, we've got some spam, but no questions. Okay, cool, moving along. All right, now that we've done that, we need to create a polar network. And when we do this, we need to be sure that we create at least one LND node that is running our custom version of LND 0.15.99. So if you're familiar with Polar, you just come in here and say, all right, I'd like this many LND nodes, this many Core Lightning nodes. You need at least one Bitcoin Core node to run on the backend. But here also we can do our custom node, and so you need at least one of these running this version of LND. All right, there we go. And then we start up our network. It will take a second for all of this to start up. In this example here, Alice is the one that's running LND 0.15.99, the version that we need. All right. So now that we have successfully created an LND node that is running the version that we need to go into that node and get some data from it, because we're going to have to tell Taro, the Taro daemon, we're going to have to tell Taro D how to talk to this particular node. So Taro works with an LND node, and it uses that LND node for a lot of different functionality that we won't dive into too much here, but it needs to talk to an LND node. So we need to give it all the information to tell it how to talk to LND. So what we go to is, so we're going to need the port that LND is running on. We're going to need the location of the admin macaroon file and the location of the TLS cert. So if you go here and just, Polar's got this great UI. So if you just click on Alice's node, then you'll get this tab over on the side that comes up. You can click on info, but here we'll click on connect and get this gRPC host, right? And click on this. So LND by default runs on port 0009, but in a RegTest Polar network like this, you might have a number of different LND nodes all running on slightly different ports. So you just have to check which port your custom node is running on. And you can just click this handy little icon right here, which will allow you just to copy that information. Then you can just come down here, make sure you're on file paths, and you can also get the TLS cert. Again, just click on that location, save it in the admin macaroon file, click on that. So if you're following along here, once you get to this point, just copy all this information, maybe just dump it into a text file because we'll be using it again in a minute after we get Taro installed. Okay. All right, so we'll come back to this because obviously we can't have Taro talking to LND until we have installed Taro. But this just gives you an idea of why we need this information. Once we get Taro D installed and working, we're going to have to give it, we're going to have to start it up with this command, tell it it's running on RegTest. And here I've kind of color coded this to make this a little bit easier to read. This is where you give it the port info. This is where you give it the macaroon path. And this is where you give it the TLS cert path. All right. Now we're going to talk about if you're installing this on a testnet node. Here's where we do the live demo part where I am logged into one of my testnet nodes, and I will walk through the process of installing Taro on this node. So any questions thus far? Questions, comments, concerns, whatever you got. See how we're doing on time. Okay, we're doing pretty decent. Clear so far, everyone good? All right, I'm going to interpret your silence as encouragement to continue because everything's going swimmingly. All right, so let's get into the testnet setup. So I think what I'm going to do here, yeah, that's right. No news equals good news. That's right. I'm going to assume everything is going perfectly because no one has said otherwise. Just trying to keep up with the slides. Okay, cool. Let me also go back. Hold on. Exit here. I kind of have to move through at a decent pace, but again, this link, and I think I can do this here. I'm just going to copy this as well and drop that into the chat. Can I chat? I'm not sure if I can drop something in there, but you can scan this QR code and this will bring you to the slides as well. So you can have them up if there's a slide you need to go back to or reference. Cool. And then I think all this will still be up on YouTube, right? So we'll be able to come back to it later. Cool. Let's see where we are. Okay. So now we're going to go to the testnet setup. And I'm kind of going to keep the slides like this because I'm going to go back and forth between GitHub and my terminal window, etc. So again, same thing here, because Taro is so new, we have to switch to a special branch or the master branch of LND to make it able to talk correctly to Taro. So here, let me know if you all can see this. I am logged into, why am I in this one too? Let me close out of that. Okay. I am logged into a testnet node of mine. So it's here, I'm on testnet. Here's this node. I created this node to play with some LSATs, which are fun, but we're going to also use this node for Taro. And I have a few active channels, so a bit of connection to the network here. And you can see here I have a Ubuntu user and everything set up as Ubuntu user. And you can see I have all kinds of things installed on this machine, like Aperture here. But here is where I have LND installed. You can see I've got LND running here just in the Ubuntu users home directory. And also that's where I'm going to install Taro, just to make it easier for Taro. And it just keeps it simple. So all in one place, Taro and LND can talk to each other. All right. And here, let me also go back to get info, and we can see the version here that I'm running. So 0.15.99. And I updated this node just like a week ago. So hopefully that means everything will run smoothly. Okay. So if you are running a testnet node and you're maybe on, 0.15.2 or 3, or maybe even on 0.14, you are going to have to update your LND to this version. So, what we would do, what we would do is stop LND, right? LNCLI stop. If you're on testnet, you always have to add this -- network equals testnet. So stop LND, go into the LND directory, switch over to the master branch, pull down the latest code from the repo, and then rebuild it, making sure you use at least these 4 tags here. I generally use a few more than that. You can use whatever is appropriate for your setup, but make sure you at least have these 4. So just pull down the latest from the master branch, rebuild it using at least those 4 tags. And these instructions are also here in the Taro repo. So you do that. That will take a couple minutes for LND to rebuild. Hold on, we have a question. Someone's having trouble with Docker. Yes, that can happen. But yeah, I think this is all being recorded, so you can come back to it later. And of course, the slides, we'll keep those available so you can go reference those as well. All right. So then you have to give LND a couple minutes to rebuild, and then you should be good. Just start LND up again, whatever method you use on your server. I like to use systemd, so I started up that way, but just check that it's running again and that it's on that version. And I just do lncli get info to validate that. You can the output here and check the version. All right, cool. So moving along, no, that's not what I wanted to do. Moving along here to the next slide. Yep, you can also use this command and just we're chasing that. So once we got that, we're all good. All right, now is the fun part. Now is where we install and make the Taro daemon. So I will do that now on my local machine. So if we do here, you can see that I've done this a couple of times in the past because that's me just very dodgy way to just, clear that out is by just renaming that data directory. But I deleted the Taro repo and deleted the binaries that it created, and we're going to rebuild it here. So first things first, I'm just going to go to the Taro repo, github/lightninglabs/Taro. I am going to copy this so I can clone it. Again, I am here in my Ubuntu users home directory. I just do git clone. Boom. Hopefully that'll be nice and simple. You can see that creates the Taro directory down here. I'm just going to go in there, just make sure I have what I'm expecting. Yep, tons of stuff, right? So then we'll go back to our instructions. All you do is run make install. In theory, very simple. Let's see how we go. We'll give that a second to build. Any questions on this process thus far? No? All right, cool. Well, if no one's got any questions, then we're just going to have to watch this build for a minute, which isn't terribly exciting. But it shouldn't be too long. Let's see what we got next. Yep, cool. All right, so I'm also going to get a text document. There we go. I'm just going to move this over here off to the side because I'm going to use this. Again, I still need to give Taro the port info, the location of the admin macaroon, and the TLS cert. So I'll get prepped and ready to do that. Cool. Are there any restrictions for who can access the Taro daemon, or is it 100% open to all? Well, if you mean like the repo, this is entirely public now, so anyone can access this. This is public. You all can go in and fork it, whatever you like. So if that was the question, if it's more a question of running it, oh, we're done, excellent. Then I mean, whoever has access to your server, right? So what I'm going to do here is go back to the Ubuntu users home directory. Then we're going to go to go bin. So I have Go installed on here. LND and Taro are written in Go. And I'm going to go here, and we can see, ta-da, we've now created binaries for the Taro daemon and Taro CLI. So let's go back here. And what we want to do, yep, can verify that you have new binaries in your Go path. Next, we want to get this data, admin macaroon, TLS cert, and LND port. This is my favorite Ubuntu command that I can never quite remember. So I have to just keep it around constantly. This just shows, oh crap, what's my password for this server? Hold on. There we go, ta-da. It shows everything that's running. So I can, again, check here that we have LND running. And I can see that here on this machine, it is using the default port of 10009. So that makes it pretty easy to connect there. All right, now we also need to get the admin macaroon and the TLS cert. So all of this is in the .lnd directory. We'll come here. Here's where our TLS cert is. So this is really simple, right? It's just going to be right here. And I'm copying all of this down into my text doc because I will use it when I start up the Taro daemon. Oops, there we go. And then that's just tls.cert. Cool. Now I need to remember where the admin macaroon is. I'm pretty sure it's at data. is it, graph? I can't remember if it's graph or chain. Hold on. Let's come here and cheat. Data chain. Okay. Thank you. I did the wrong one. All right. All right. Bitcoin, Testnet, and there it is. So here's the path that I need to find it. And that will go in my text doc. And then it is here. Where is it? Admin.macaron. And of course, I can give this to Taro because it's running on my server, and this is fine. But you do not otherwise want to ever give out that bit of information, because then someone has admin access to your L&D node, which could be a problem. All right. So we know the port that we're running on. We have the path to the TLS cert, and we have the path to the admin macaron. All right. Oh, here we go. We have a question. Brian asks, if I created a Taro asset and want to send it to my friend, do they need to install and run Taro and give me a Taro address to be able to receive it? The answer is yes. And we'll walk through, if we have time, and certainly in the slides, there's some instructions on how you can send Taro assets to a friend. Now, how those sends are happening is like actively in production, like being worked on now. So there'll be a couple of different methods for, I think, like synchronous and asynchronous for like how to send assets. But at the moment, yes, Brian, you're absolutely correct. You definitely need to, if I wanted to send you some assets, you would have to generate an address for me, and we'll talk through, if we have time, on the process for how we could do that. Okay, cool. Let's see where we are here. No problem. All right. So now we're going to attempt to start up our Taro daemon. So I'm going to take this command here, which I've put in my notes, copied over to my text file so I can put all the appropriate values in there. So you can follow along with what I'm doing here. I'll put this on the screen. Couple of things to keep an eye out for. A lot of times, Google Docs, etc., like to reformat the -- so just make sure it didn't do that to you. We do have to tell it that we're running on Testnet. If you have a polar setup, then you would change this to reg test. Just add this in there so it gives us a nice debug level. LND host, this is accurate. I'm running on localhost, and that's the correct port. This admin macaron path, is it the same as I have here? I'm just going to copy what I have here to be safe. I'm going to use the full path just to avoid any potential issues there, because I know when it comes to the TLS path, I've gotten an error before where I tried to use just the shortcut, the tilde there, and it threw an error for me. So we're going to make sure we use the full path so that doesn't happen here. Okay. And now here's where everything can go wrong in our demo if we run into any problems here. So cross your fingers for me. Here we go. We have Taro D, testnet, debug level, host, macaron path, and TLS path. Cross your fingers. Hey, that looks pretty good. I think it's going well. One thing I forgot. I'm going to have to pull this back up. So we now are successfully running Taro daemon. Woohoo! And this, should be roughly what your output looks like. I am going to have to log in. Hold on, let me just go here, because I'm going to have to open a new terminal window because I want to keep this running in this window because I don't have it set up via systemd or anything to run in the background. So I am once again going to, in this tab, log into my server, and there we go. And let's see. Cool, and we now have Taro running. Look at that. Woohoo. Okay, so it's working. So let me close this. All right, let's go back to Polar. Again, you would do the same process on your local machine. If you're running Polar, you would go through this whole Taro installation process on your local machine, and then you would take that data you took from the Polar UI to connect to your specialized LND node and plug it into this command. You can see the paths are going to be a little bit different if you're running on Polar. And hopefully get it up and running. And John says he is running Taro. Excellent. We have at least achieved some success here today. Cool. So now that we've done that, we're going to attempt to mint some assets. I'll pause for questions. We're about 45 minutes into the workshop. Anyone have any questions at this point before we attempt to mint some assets? No? Okay, cool. All right. Keep in mind, if you're doing this on Polar, that you do need to make sure that your node that you're running has some Bitcoin on it, because we are doing, Bitcoin like on-chain transactions here. The minting process is an on-chain transaction, so you do have to have some Bitcoin to send that transaction. And if you're running on Polar, you'll want to hit the mine button. Make sure you mine some blocks. Then your Bitcoin node will have some, reg test Bitcoin. Send that to your LND node. And then in this process, you have to make sure you continuously mine blocks to keep the blockchain moving along. That's if you're on Polar. Here we're demonstrating Testnet, and I'm pretty sure this node of mine does have some Testnet coins, so we should be good. Yes, we're all going to mint it. Yes, love it. Excellent. We'll try. Fingers crossed. We'll try and mint some assets. Okay, so here's the command that I am going to use to mint some assets. Let's again copy this, drop it into my text doc here, and talk through what we're going to do. So now we've got the Taro daemon up and running. We're switching over to using the Taro CLI. I am on Testnet. So I'm going to put Testnet in here, but if you're on Polar, you'd put reg test. Okay, so then we're saying, hey, we're going to do something with some assets. We're going to do mint. We have to tell it the type. Here, this is the syntax that works here, just -- type space normal. So it's just a normal asset type. I'm going to give it a name. I'm just going to call it Magic Internet Money. Instead of 100, let's be ambitious and go with 1,000 this time. Although from the perspective of the Bitcoin blockchain, it doesn't really matter what number I put in here, right? This all just gets hashed down into a specific value, which gets added via tap tweak to that Taproot transaction. All right, so we can add metadata. I'm just going to declare this to be fantastic money. And then we're adding this skip batch option because Taro can allow you to mint a number of assets essentially in one Bitcoin transaction, right? So it'll sort of try and batch that for you. But because at the moment I'm only planning this one release of 1,000 Magic Internet monies, I can just add skip batch so it does it straight away. All right, so let's go ahead and try this. I'm going to copy this command. We'll go back over to my testnet node, and we'll try minting. Cross your fingers. Let's see what happens. Hey, that is good news. So batch key is the output that you want to see there if you've done this successfully. So let me know if you have questions. We're also going to move along to the next one where we can list these assets and take a look at them. Here is my backup plan in case this doesn't work, was just to show you a video of a time when it did work, but thankfully it worked. So that is unnecessary. And we can skip to the next slide. All right, so again, here we go. We can list some assets. I'm going to copy this command, again, being careful that Google Docs didn't reformat that for me. But it's very simple. Again, we're using the Taro CLI. We're telling it that we're on testnet, and we are telling it, hey, we want to deal with some assets, and what we want to do with those is list them. So let's see how this works for us today. Ta-da! So let's go through this briefly, although there's a lot of stuff happening here, we'll briefly go through what's happening. So we have a name, it's magic internet money, Genesis point. I think this is the out point of the transaction where we minted them. This is, I guess, a hash of our metadata. This is our asset ID, which is cool. This Genesis bootstrap info, this is, gosh, it's just to say it's information about the asset that you created. I'm going to copy this because the current process for sending someone assets requires that I send them this information. So I'll keep that on standby. All right, we have asset type normal. You can see I have 1,000 magic internet monies. We have all this, you know, script key, chain anchor, anchor transaction, all this various different stuff, internal key. Okay. All right, so we have a question here. What's happening on chain when minting Taro assets? So let's come back up here to this diagram. So what we've done is, right, our, you know, Taro D has gone and created all these Merkle trees, right? Well, it's sort of a, anyhow, it's created a giant Merkle tree, a tree of trees, right? And it's then gone and, so Taro's created that, Taro D created that Merkle tree, and then condensed it down to this root hash. It keeps all of that Merkle data, right, because it needs it for proofs and stuff when we're doing transfers. But it takes all that data, condensed it down into the hash. It then works with LND to create a Taproot transaction. So it creates a Taproot transaction and via tap tweak, embeds that Merkle data into the Taproot transaction and then does an on-chain transaction. So what we did is we took some inputs here from my testnet node. We went through this whole process where Taro D is working with LND, which is working with Bitcoin D, it's all which I have running on my testnet node. Went through this whole process, created a transaction where we have a UTXO, and inside that UTXO, we have committed to all of that Taro asset data. So essentially what we've done here when we minted was just create all of this data, all of these Merkle trees, which are our Taro assets, and just committed to them on the blockchain. So if I don't need to tell anyone ever that I've created this asset, of course, y'all watch me do it, but I wouldn't necessarily have to ever tell anyone. But in the future, if I wanted to say, hey, I own, 1,000 magic internet monies, and I can prove it to you because I can provide these proofs of where I included this in the Merkle tree, and then I can show you that I committed to this on the Bitcoin blockchain. So essentially, Taro D created the assets, and then we committed to them on the Bitcoin testnet blockchain. Does that answer the question for you? Let me know. So we are about at time. I didn't really want to go much more than an hour, so we have 6 minutes left. If anyone has a testnet Taro node up and running, let me know because we can attempt to do a send with each other. Now is also a great time for further questions if anyone has them. While I'm waiting for questions, I'm just going to walk through the process that we would use for sending. All right, so let's briefly go back to our nice slideshow presentation. All right, so if you're running on the testnet or if you have a sophisticated Polar network running, you can send Taro assets between nodes. Here's the current workflow. Again, this is all very new and in progress, but this is currently how we would do it. All right, the sending node needs to communicate to the receiving node how many units of the assets they intend to send. So if I'm going to send Bob 100 magic internet monies, then the first thing I have to do is take that Genesis bootstrap info key and send it to Bob. And this contains the asset ID. The receiving node, Bob in this example, needs to generate a receiving address and communicate that back to the sending node, which is me. The sending node sends the asset to the receiving node. Okay, right, it's where you can find the Genesis bootstrap info key. so this is the command that Bob, so once I send Bob that Genesis Bootstrap info key and tell him that I'm going to send him 100, I guess this is, what we would have agreed to, he uses this command to generate that address. Leo, who gave the presentation earlier in the week, was also nice enough to send me this GIF. Is it on the next one? Here we go. This is a nice little GIF he made to show the creation of the address. So you can see he's using that command, and then he gets this output. I think this is what we want, this Taro testnet address right here. So then what I would do is I would then, once Bob sends me the address, I'd again use Taro CLI, tell it we're on testnet. I will say, hey, I want to do some stuff with assets. In this case, I want to send. And here is the address that I am sending to. And because I've already communicated to Bob that I'm sending 100, I think that that's baked into this address here. So that's a bit of a complex workflow at the moment. I believe that that's currently under construction. But that's roughly how you would do it if you all want to, get on testnet with your friends and send some transactions back and forth. So what I'll leave you with here is just, because we're about at the hour point, if we don't have any questions, I'll just leave you with all of these resources. Obviously, you can go to the repo, hear all the various different BIPs that are involved in this whole protocol. The docs are a fabulous place to go, which links out to all of these various other things. So this is really the primary place you want to go, docs.lightning.engineering/the-lightning-network/Taro. There is an API. Here's some information on that. And then we have the Taro intro video and the Taro demo video. So I'll leave you with that then. Thank you. How do I? There we go. Hold on. Let's stop screen. All right.
That was fantastic.
Excellent. Cool.
That was really great. I've got a couple of kind of very simple, high-level questions. If anyone has any more technical questions, obviously feel free to just drop them in the comments. But yeah, that was great. I'm really looking forward to. I think a few people kind of hopefully got that up and running. Would have been cool to have done a live swap, but I think some people will probably be doing this async as well, so maybe we can try that.
Yeah, we go through it a bit fast in a demo, so hopefully people can come back.
Yeah, it's always like that, and I guess you probably
Yeah.
have to have a couple of monitors up, one with you on it, and then one with the CLI. So
yeah,
I had one question regarding the assets. So let's say you just minted 1,000 magic internet coins. If you wanted to increase the supply of that asset from 1,000 to 2,000, does it have to be done via your node? Does it have to, so let's say Alice mints 1,000 magic internet coins. If you want to mint more, does it have to be done via Alice, or can Bob come along and say, I want to increase the supply and mint an extra 1,000? How does that work?
Great question. I think this is, please reference the docs, so I'm not sure I'm going to get this exactly technically correct, but I believe the idea is that you can have like an asset group key, right? So if I'm issuing some sort of asset, right, and like I'm Alice here, I'm issuing an asset, I know that I might want to issue more of those in the future. Maybe I've got some cool video game and I'm issuing assets inside that video game, and I'm going to want to do more, next month for some other challenge or whatever it is. So I think then that I have to have that asset group key, like that top level asset group key, and then I can use that to mint more like groups, more tranches of these assets. So I think it's dependent upon that particular private key. So if Bob, worked at my video game company with me, I could maybe say, hey, Bob, we need to mint another round of these, but I think he would have to have that same key is how I believe it works at the moment. Yeah.
Right. Okay. And do assets have, are they assigned sort of tickers as well? So let's say you had magic internet coins, maybe it would be shortened to MIC. Is there a way of ensuring that someone, or if they wanted to mint more MIC, they would have to do it with that private key rather than maybe creating magic internet coins, but maybe it's
right, because I could
MIT
just give it
right?
whatever name or metadata I wanted to, right? So someone could spoof, like, let's say my magic internet money is super popular, and someone could just spoof it, right? And the idea is that with all of the proofs that you provide in a transaction, in a send, you would be able to trace that back all the way back to the Genesis out point used when I initially minted those assets. So, and then you could see that particular key, right? Basically, all of the magic internet money created would have a way to be linked back to that initial that Genesis out point on the Bitcoin blockchain. So if someone came along and Bob was mad at me, left the business, wanted to go, mint counterfeit magic internet money, he wouldn't be able to provide the proofs that link all the way back to that initial transaction. So that's how you would prevent that from happening.
Right, I see. How dare Bob?
How dare he?
Yes. Cool. And then I guess from obviously I'm a UX designer, so I kind of think of this from a UX standpoint. But when Leo gave his talk on Monday, I was sort of thinking a little bit about how the sort of liquidity of these assets is going to be managed throughout the network. So I presume this is something that Lightning Labs is actively thinking about or has sort of solved. But could you talk a little bit about how you guys envisage these sort of liquidity running so that Alice, Bob, or Charlie, whoever it is, can receive magic internet money? Are they going to have to just do it by manually sort of setting up a channel to you as well? Or do you sort of envisage this being done through larger routing nodes or exchanges, things like that?
Great question. So this is talking about specifically on the Lightning Network. Let's say people are exchanging the magic internet money on the Lightning Network with each other. And we all know that, if you're running a Lightning node, you have to manage your liquidity, right? So I don't have the slide for the Lightning stuff in this particular slide deck, or I'd pull that up. But the idea is that how this is envisioned at the moment is at least that these would be edge nodes, right? So maybe I'm Alice, maybe I have a specific Taro channel with Bob, and then all the way at the other end of the network, Zane has a Taro channel with Charlie, right? And so these are on the edges of the network. And all through the middle of the network, no one needs to care about Taro at all. And the Lightning graph, the network graph as it currently exists, does not account for Taro channels. So these would be on the edges. And then I, as someone who's running a Taro node and has a Taro channel, I need to worry about Taro liquidity, like the liquidity of the assets in that channel. But everyone else on the network doesn't need to care at all. And I can route through that channel out into, the regular Lightning network using regular, HTLCs, Bitcoin HTLCs, and then get that all the way over to Zane on the opposite side of the network. And so anyone with those Taro channels then needs to concern themselves with the liquidity of the assets in those channels, but no one else does. And yes, it's something that's definitely being considered a lot. What sort of services could you use to, help maintain or manage the liquidity, Taro asset liquidity, right? And, I kind of how now we have things like Pool and Loop to manage Bitcoin liquidity. And so what kind of services would we have to manage Taro liquidity, right? That's certainly, something that's being thought about.
Cool. I saw there was a comment from Brian. Brian said he managed to mint some Atlanta BitDev bucks.
All right.
Great job, Brian.
I want some. Yeah.
Cool. So how does Brian go about sending those to you, Hannah?
He would have to send me that bootstrap key info. I'm saying that wrong, but the bootstrap info, and then I would use that to generate an address and send it back to him. Yeah.
Cool.
That's the current process. Yeah. Hey.
Hey, awesome presentation. Yeah, I got pretty far with it. At least I got the Taro running.
Excellent. Good stuff.
Yeah. I wanted to ask, what does multi-sig look like on Taro for the issuance of those assets?
Ooh, good question. All right, so it's all using Taproot stuff, right?
Okay.
And it's so at the moment, the Taro daemon as it exists now is for on-chain only, right? So the Lightning functionality for that is currently under construction, and of course, obviously, Lightning channels are these multi-sig addresses. So you would have to do, Taproot multi-sig, right? Musig stuff, like all of this to get to create those sort of Taproot Lightning channels. So that's going to be necessary there to have the Taro enabled Lightning channels. And that's being worked on and is planned for LND 0.16. So.
Okay. So if it's Taproot, then that means you could do a 998 out of 999.
Sure could.
I'm
That's
sorry.
right.
It may be a sensitive topic, but
No, you absolutely could, and we are ready for that. Yes.
okay, gotcha. All right. Yeah. What are some of the kind of things that like you're hoping to see, maybe in terms of like tooling, and stuff that maybe Lightning Labs isn't necessarily working on now that maybe some makers in the space can hop on, because like this is a new concept within Bitcoin, right? To have these kind of like tokens in such a way. Yeah, what's some of the application infrastructure that's going to be needed for this, just to get the people's minds going.
Yeah, no, there's all kinds of stuff. I would hope to see this stuff. First things we might see are maybe some universes. So we didn't really talk about that much, but that's sort of the idea of, you can think of it as like a block explorer, except for Taro assets. So if I'm Alice and I have this video game and I'm creating these assets in the video game, because Taro can be just like very, very private, right? I don't have to tell anyone that I've minted assets or that I'm exchanging them with you or anyone else, right? But if I've got a video game and I want to promote these assets that I've created, then I want people to know about them. And so I might myself or use someone else's sort of universe, which is kind of like, think of it as like a blockchain explorer or a Lightning Network explorer, except for Taro and for Taro assets. And so it would be a service that maintains a lot of this data. Again, entirely opt-in. You don't ever have to give any of your Taro data to a universe. But in a lot of situations, people may want to. So I'm really excited to see universes pop up, excited to see how Taro might get integrated maybe into some wallets, or I think, stable coins is something we're going to see. And then, things like, game assets, I think might very well, I think quite likely we'll see. And so any sort of tooling around how to get this stuff, how to integrate this stuff. So maybe doing like writing libraries, because this is all running in Go, maybe writing libraries to have this run with connect to other programming languages or other systems, like libraries like that, I think would be really, really fabulous. So yeah, lots to build there.
That's really interesting. The game asset thing that you mentioned. I guess those would be kind of like I used to play this game Moo Online. It's really obscure, really old MMORPG, but like it would be something like a body armor that's equal to everyone else's body armor, right? I guess the question there is like, those are like fungible, right?
Right.
Like
so
fungible
yeah.
assets, yeah.
And we have to think about the difference between, unique collectible assets and fungible assets. And the cool thing about the fungible assets is that that's, easily exchangeable. Like the functionality for exchanging that on the Lightning Network is being built now. So that's super cool. So even like, in some video games, I am not a gamer, so I'm going to get this all wrong, but I understand in a lot of games you can collect like gold coins or all sorts of, my kids love to play Roblox. And so there's like these Robux that I'm always buying for them that you have to use in the game, So things of this variety are fungible. And I would absolutely think that we will see in a lot of different systems like that at some point. Yeah.
Might there be a bit of off-chain data that has to be stored with these assets as well? And
Yes.
do you know like where so for example, there's the bootstrap information, right? But what about the like what other kind of data would someone have to store, and where should they store it? Actually?
Where does that data live? Yeah, it's a great question. A question I had when I was, going through all this documentation, trying to figure it out, right? So absolutely there is data because what's happened is these Taro assets are these Merkle trees. It's kind of how I think of it. The Taro assets are the Merkle trees, and then you just commit to them in the Bitcoin blockchain. But you have to actually maintain those Merkle trees because you have to provide proofs for them when transferring assets. So those Merkle trees essentially live in the Taro node. And there's some, or if you have a Taro-enabled wallet, then they would live in your wallet, kind of how your wallet has to maintain keys for you. It would also, or if you have multi-sig, it has to maintain multi-sig scripts. It would also have to maintain that Taro Merkle tree data. And right now, how it works, there's some interplay between, I think LND does some key management and Taro manages the actual Merkle tree data. Like there's some interplay between how stuff is managed there. But essentially, you can think of it of your Taro node, or perhaps in the future, a Taro wallet. That's where those Merkle trees are living. And then you just periodically commit to them on the Bitcoin blockchain.
Gotcha. There are some work being done on cloud storage, remote cloud storage, encrypted cloud storage, and stuff like that as well. So I can imagine that that kind of playing a part there. Also,
don't put your keys in the cloud. Be careful. But yes, maybe Merkle trees could go in the cloud.
Well, yeah, for sure. Like for example, there's this project called Photon. And what they do is it's just like your password. They encrypt your password and store it in the keychain essentially. And these kind of things are for like mobile apps and wallets and stuff like that. There's a question: will LL be producing code to run and maintain universes?
Yes. So universe, I think at least base universe functionality. So there's different varieties of universes, but the simplest, the base universe functionality, I think it is being built now, or being planned to be built now for the Taro daemon. Right, so some functionality will be built there, and of course that's all open source. I don't know if it'll actually be any sort of separate library for it. I think it'll just be some base functionality built into the Taro daemon, but don't hold me to that because the stuff is all in flux. Yeah.
Christoph asked, will there be a Marvel Cinematic Universe?
Of course there will be. No, I don't know.
So I guess the universe code that you guys are producing for the base universe would essentially be for kind of like the administration, right? And probably something a bit more developer-y focused, I'm assuming.
Well, for the universe functionality?
Something more admin focused, less consumer side, something that you can
yes. Yeah, I think so. And I think there are a number of people out there now who have some interest in building Taro universes, which are more consumer focused, right? Just the same way we use, a Lightning Network, Explorer, etc. I've heard some talk of that. At this point, I should definitely shill the Slack, the LND Slack, where there's a Taro channel, and people can go and discuss this stuff. And if they have additional questions, that's a great place to ask it too.
Okay. Well, I think that's it on my end. Thank you so much for spending time and doing this presentation. How do you want to close it out? What's the next steps? You want to?
I would just tell people so I'm on the Twitters as always, but definitely go to the docs. Docs.lightning.engineering. There's tons of Taro information there. That's a great place to start. And then do go on lightning.engineering. If you scroll down to the bottom, there's a link to the Slack. where you can go to, and there's a Taro channel. And any questions that we didn't cover here, like I go check that channel pretty much every day. So please go there, ask all your questions there, and yeah, we'd be happy to have a chat with you.
Thanks so much.
Excellent.
You know, I know we said we were going to close it off, but then like one question just like got stuck in my head now.
Let's hear it. What you got?
Is it possible to have controls over like, so let's say someone mints some token. Is it possible to say that only a specific address could move those tokens after it?
So the idea is that tokens get minted essentially in a Bitcoin UTXO. So whoever controls that Bitcoin UTXO is who can sort of enable the transfer of those assets to another UTXO, or can like update their status. So does that sort of answer the question? Like if I'm controlling that key for that UTXO, then like I have to sign off on changes to that.
Okay, but can you put like a layer of permissioning so that that new UTXO that gets minted does like it I guess what it is a multi-sig, right? The UTXO would get sent to a multi-sig with the new owner, and then that.
So if you're talking about Lightning, then that's in a multi-sig channel, right? But if we're talking about just basic on-chain minting, like we demoed here, because that private key lives on my Taro and LND node, right? That lives there. Those assets, that magic internet money I just minted, can't be moved without my node signing off on it. But when we're talking about Lightning, then that is multi-sig, and then you have to go through the same signing process as you would for any Lightning transaction.
It's probably not something that should be encouraged, but I could definitely see a use case where the issuer kind of wants to like put a hold on something, but very, very against some of the principles in Bitcoin here.
Well, you can have entirely non-custodial Taro assets, right? If Brian there, like if he wants to send me some of those coins he minted in Atlanta, right? And we do a transaction or transfer called a split, then he's sending them to a UTXO, a Bitcoin UTXO that I control. So then that's entirely in my control once I have those. And Brian then at that point gets no more say over how I spend those Atlanta BitDev bucks.
Fair. All right, thank you so much, Hannah. Check it out, docs.lightning.engineering. How do we find you on Twitter?
H Michelle Rose is my Twitter handle. Yes.
All right. Thank you so much. Take care.
All right. Thank you. It was fun.
Thanks, Hannah. Appreciate it.